Hello everybody, welcome to a new DIY guide on the 2012 Range Rover Sport with the 3-liter SDV6 diesel engine. Now ever since a couple of months ago, I started hearing a rather unpleasant sound coming from the front suspension, a sort of knock, which I will show you in a couple of minutes. Most likely it's an issue with one of the bushings from the lower control arm. And ever since I got that diagnostic, I started planning for some work to update the bushings and ball joints across the entire front suspension on our Range Rover. With the rationale being that if I'm going to swap or replace one of the bushings and go through all that hassle, because you probably know that the replacement of the bushings on the front suspension and rear as well can be a fairly difficult job. It actually made sense to spend some time and replace all of them, since all the bushings and ball joints are the original ones that came with the car from nearly 11 years ago. And today we're starting with the hopefully easier of the two jobs, which is the top control arms or upper control arms. And I say it's easier in theory, at least, because the components are comparatively smaller. So hopefully it should be easier to press them out and press new components in. Now at the time of filming, which is September 2023, the car just clocked slightly over 145,000 kilometers, and it is almost 11 years old from the moment it left the factory, which was October 2012. And it's still behaving very, very well, thank God. Everything is fine with the exception of the suspension issue that we are tackling in these videos. And now let me show you the exact problem during a small test drive. And here's what happens when I'm at a steady speed and just tap on the brakes. If you listen carefully to that last bit, I think you can ever so slightly distinguish a very specific thump, lower frequency thump, apart from the background noise. And to top it off, here's what happens when I drive on a really bad road full of potholes. Okay, so ultimately this is the noise that we're chasing and the one that we want to fix. And the general consensus for this particular vehicle and the Disco 3 and the Disco 4 as well, because they share the same chassis elements more or less, is that this can be one of two things. Either there's something loose in the anti-roll bar setup, so either the anti-roll bar bushings or the sway bar end links, or the most likely culprit are the rear bushings from the lower control arms, which are hydro bushes. We'll talk a bit more about those in a different video, but those are the ones that tend to wear out the quickest. All right, the car is stopped. And before we proceed with the removal of the wheels and the removal of the control arms, we need to perform two initial steps, which are very important once we install the control arm back with the new bushings. I'll explain in more detail why these steps are necessary when we get there, but for now let's just go through them. Now the very first one implies marking the top of the fender, and we need to measure the distance between this point and the center of the wheel hub down there. And if I measure the rough distance, it's between 46.5 and 47 centimeters. And I also did the same operation on the right hand side, and there the distance is between 47 and 47.5. So a delta of 5, 6, 7 millimeters, which is explained a bit by the fact that my driveway has a small tilt. And we will also be working with the workshop manual for this operation, and I'll give you the steps in the manual as well. And you see that it says here, this is where the installation of the control arm occurs. It says set the height distance between the center of the H shaft and the edge of the fender trim to 466 millimeters. So we have this value in the manual, but we also measured for our car and we got very, very close distances as well. And the next step is to put the suspension in its lowest setting, or access height as it's called. And once I close the door, it should level down. And here is the car with its front all jacked up and supported by 2 jack stands. As a warning that I always repeat, never work underneath a car supported only by a jack. Always, and I mean always, use jack stands connected to the steel chassis, as you can see. And I've also choked the rear wheels to make sure that the car does not move. Now let's take the wheels off. And here comes the wheel out. And I'm gonna do the same on the right side of camera. And now that the front wheels are off, let's see for the fun of it if the anti-roll bar and the sway bar links are actually in good condition, because as I said before, these can be one of the culprits if you hear front suspension knocks. So with the pry bar, I'm sticking it between the lower control arm and the anti-roll bar and applying a bit of leverage. And there is no play. See, absolutely nothing, no knocking. So the end links are fine. We can try and pull on the anti-roll bar to see if the bushings are fine, and they are. There's no play. And I've checked the right side as well, and that's sturdy as well. So anti-roll bar and components are fine. However, if we take a look at the prime suspect, which is the rear bushing from the lower control arm, the one from here, if I apply just a little bit of leverage, you see how easy it is to move it. So most likely that's our main problem, but we'll sort that out in a video dedicated solely to the lower control arms. As I said, for now, we're focusing only on the upper ones. And now we're gonna start the disassembly of the left-hand side front upper control arm. And we're gonna follow the steps in the manual, but not necessarily in the order they are given in the manual. So first things first, we're gonna remove the wheel speed sensor and the brake pad wear sensor, as well as the brake line connections from the control arm. So steps 5 and 6. And underneath the control arm, this front wire is our brake pad wear sensor, the one that goes over here. And you can see that it's actually covering this bolt that we need to remove. So let's first pull it out gently so that we can now access that bolt. And that bolt needs a Torx T30 head. And out it comes. And with this bracket disconnected, you can connect the brake pad wear sensor back and also put the bolt here because it's kept in place by the sensor wire so as not to lose it. Next, we have this bolt back here, which holds a bracket that holds the flexible brake line to the front left caliper. And that bolt takes a 10mm hex head. Now gently wiggle the bracket out like so and store the bolt in a secure location. The next step is to disconnect the height sensor link arm, as you can see in the drawing here. However, it can be a bit tricky to do this, especially if the connecting point has rusted. And it may actually be easier to simply remove this bolt here that you see, which actually holds in place a bracket that connects to the sensor arm. And this bolt also takes a Torx T30. And we're actually talking about this bolt over here. And out it comes together with the sensor arm. Okay. Take a hold of the bolt and store it somewhere safely so as not to lose it. The next step is to disconnect the sway bar end link from the control arm. And it gives us a few cautions: to use a Torx socket to prevent the ball joint from rotating while we remove the nut, to also note the position of a steel washer, And they also tell us to discard the nut and later use a new one, but I don't have a new one, so I have to reuse the one that I already have. And here's the end link connection. It's a 21mm hex nut. However, its position is a bit awkward because you don't have too much space between the nut and the air spring. So the best tool I could find was an offset wrench, which does fit pretty well. As you can see. Now, if it does happen to you that you try and untie the nut and you actually do spin the ball joint, then to hold the ball joint in place, you need a Torx T50 bit like the one here. As I'm spinning it, you see the ratchet jams against the control arm, and then it becomes much easier to untie the nut. All right, nut is loose. Try and remove all of these, and the nut as well. And the control arm should come out quite easily. And this is the steel washer that the manual warns us to keep track of. We definitely do not want to lose this. Now I'm gonna take the washer and store it safe until reinstallation. And this is why it tells us that we should replace the nut, because it has this nylon insert here. But as I said, I don't have a replacement, and this still looks in fairly good condition. So I'll keep this safe as well. Now the next step for us is to disconnect the control arm's ball joint at the top from the knuckle. And here's the nut in question. Now to hold the ball joint in place, similar to the sway bar end links ball joint from earlier, we need a Torx T30, and this is a good tool to use here because it takes up very little space. Now the size of the nut is hex 18mm. When I don't have a hex of that size, the only thing I do have is a crowfoot extension together with a breaker bar to first slacken this off a little bit. Okay, and hopefully I've slackened it enough with the breaker bar. Let's switch to a ratchet, or even better, any kind of wrench or spanner, like so. And I've slackened the nut just enough to be able to install this kind of ball joint extractor or separator. If you don't have one of these, just take a big hammer and strike either on the knuckle. You can also hit from the bottom up to the nut. This is definitely okay if you will be replacing the ball joint and the nut. In my case with this extractor, I just need a 19mm hex bit to turn, and it should pop up at some point. There it is, it popped. And now before fully removing the nut and disconnecting the upper control arm from the knuckle, make absolutely sure to tie down the knuckle against some rigid point on the chassis, for example against the air spring here, because the risk is once the upper control arm gets disconnected, if the knuckle falls towards the outside of the car, it's going to pull on the CV axis, which is then going to simply dislocate or disconnect the inner CV joint, and you don't want that to happen. And now we can finally disconnect the ball joint from the knuckle. Remember to use the Torx T30 to hold the ball joint in place as you untie the nut. Okay, and there it is disconnected. And the knuckle is holding, which is perfect. And now the last part is simply to disconnect the control arm from its two main bolts. One is here and one is there. They are identical and they have 21mm hex nuts. And the first steps in the manual actually wanted us to remove this heat shield, but I'm hoping we can avoid that. What I went and did is I used a 21mm crowfoot extension with a breaker bar, and let's see if this allows us to slacken the nuts. Okay, it's starting on this one. And once you slacken it a bit, you can switch to a wrench. And slowly but surely I'm making progress. Now, if it does happen that the nut starts spinning together with the bolt, as it just happened to me, use another 18mm offset wrench here, putting it from above the control arm, because it's going to try and spin downwards, in order to hold the bolt in place, and continue untightening the nut. Slowly but surely. So here is the nut removed. And here is the bolt removed as well. Thank God. You know, this can be notoriously difficult to remove, and in extreme cases they may even need to be cut, but apparently this one only required the force of my finger to come out. Same story with the front bolt as well. We start with the 21mm crowfoot extension and a breaker bar. Okay, it's moving. Now the head of the bolt is all the way behind the air spring and fairly inaccessible. So if you want to hold the bolt in place, a better option is to use a 9mm ratchet or offset wrench, or whatever your choice is. Put the main wrench first, and then with the small 9mm one, put it on the body of the bolt, and it should jam against the chassis all the way here as you untighten the nut. And you see it's already slackened because the control arm is moving with a lot more ease. And eventually, just as before, you can switch to a normal 21mm wrench once the components are properly slackened and the nut comes out eventually. And to push the bolt out, I'm using a pipe wrench, and I'm having success. Again, thank God this second bolt wasn't rusted either. And actually I was able to extract the bolt by inserting my hand through here, and actually had quite easy access to grab it and pull it out. So the bolt is out, and with a little bit wiggle, hopefully I can take the control arm out as well. No luck. I struggled so much to avoid removing the shield, but it turns out that I do have to remove it because of this part here that's not allowing the control arm to come out. With the extreme flexibility of the control arm now disconnected, we have a lot easier access to these small bolts that hold the shield in place. So there's one at the top, 10mm hex. Okay, first one's out. And after removing the first one, here's the second one. And look at that. I removed only 2 of them, and I was able to make enough room to finally take the control arm out. Perfect. Now let's move over to the right side. So here we are on the right side, which is more or less of the same, but might as well go through all the steps again to make sure we don't miss anything in particular. So first of all, Torx T30 bolt, holding this time only the ABS sensor, because on the right hand side we do not have a brake pad wear sensor. Okay, out it comes. Next up, it's this 10mm hex bolt that holds the bracket that holds the brake line. Once that's out and the bracket is out as well, next up is this bolt here holding the bracket that holds the height sensor link, again Torx T30. Next up we have the sway bar end link nut, where the ball joint is held in place with a Torx T50 bit and a 10mm spanner that will jam against the chassis. and a 21mm closed head offset wrench to slacken off the nut. Okay, it's slackening. Here's the end link nut removed, and here's the end link itself coming out. As with the left side, this is in very good condition. So we take the washer and the nut and store them somewhere safe. Next, control arm ball joint. We hold the ball joint in place with the Torx T30 L-shaped bar, and then with a 18mm hex crowfoot extension and a breaker bar, we slacken off the nut. Like so. Next, we switch to a wrench. And we stop when the bottom of the nut is flush with the ball joint's bolt. Here's the ball joint extractor in place. And that was quick. Next, let's fully remove the nut, making sure to pin the knuckle in place against something solid as part of the chassis or the air strut. Okay, next let's slacken the nut on the rear bolts. So we have our 21mm hex crowfoot extension and our breaker bar. Okay, it's slackened. And the setup for removal of the nut and bolt uses two offset wrenches. The small one here that goes behind the chassis is a 9mm hex there that goes on the body of the bolt, just as we did on the left hand side. And then you have the large one, 21mm hex, that actually unties the nut. And so on until we're done. Now that everything's slackened off, I can remove the nut by hand. Okay, and the bolt is kind enough to come out as well. Here they are, and in fairly good condition. Hooray! And for the front bolt's nut, I'm finding no room to use the crowfoot extension and the breaker bar, so I'll just try with the two offset wrenches. It slackens off eventually, and then we continue until we remove the nut altogether. And eventually here comes the nut. And here's the bolt out as well. Just as on the left side, I stuck my hand through here while pushing the bolt from its back towards the front. Again, thank God it wasn't rusted in place, otherwise it would have been a very difficult job. And I'm really happy to say that with just a little bit of wiggle, I was able to remove the control arm. So on the right hand side, I really did not need to touch this heat shield. So perfect, we're at the point where both front upper control arms have been removed from our Range Rover. And here they are, the two control arms removed from the car. And obviously the next big step would be to press out the bushings and ball joints. But before we get to that, we have to touch on a few more details, starting with me cleaning them thoroughly with a wire brush, because I plan to paint these control arms a bit later. And here they are after an initial cleanup with the wire brush and then soap and water. So there's clear signs of rust, but this is just surface rust. So this is a purely cosmetic issue. It has no impact whatsoever on the part's functionality. The control arms are both absolutely fine. They receive no damage and can be reused. And now before we continue, it's time to make some important observations. The first observation has to do with the manufacturer of these parts. Now, these are genuine OE parts, obviously, because they came with the car, and you can tell that's the case because you see they have the Land Rover stamp on them, and this also applies to the bushings and ball joints as well. Here's a bushing, and hopefully you can see here in this corner it's stamped Land Rover, and it's the same for the other parts as well. But you're probably aware that it's not Land Rover themselves that actually forge the steel control arms and build the bushings and so on. They contract these operations to various suppliers. Now, in the case of the control arms, bushings, and ball joints, the supplier is Lemforder, the same brand that Sretan from M539 Restorations uses on most suspension components on his BMWs. Hopefully you can ever so slightly see here where my finger is. It is the Lemforder brand stamped into the rubber of the bushing. And also on the control arm, here is the Lemforder logo, okay, this triangle with an L. And this is an important detail when you do need to go and order new parts, or when the dealer or garage offers you a variety of parts to choose from. Obviously, in an ideal world, we would all buy OE, because those are certified by the vehicle manufacturer, but they're also the most expensive parts. By far, the next best alternative is to go OEM, which is to buy the part from the original equipment manufacturer that also made the parts for the car brand. As I said, Lemforder in our case. The third option is to go aftermarket, and the idea here is simple. The OEMs are typically the only ones that get the specifications, blueprints and stuff from the vehicle manufacturer and can make those parts to precise specifications. All the other manufacturers outside of the OEM will typically copy the part from the OEM and build their own parts which may or may not fit very well with the original part. In our case, it made no sense to buy anything else than Lemforder. And if you're interested in the part numbers that you need, this is the part number for the ball joints, obviously identical. And this is the part number for the bushings. Now, all 4 bushings from these 2 control arms are of the same size. So you will need 4 units of this code and 2 units of that code if you want to just replace the bushings and ball joints on the control arms. Obviously, you can go and buy new control arms with bushings and ball joints already pressed in from Lemforder. They are somewhat more expensive, but I went with the pressing part because I thought it was a nice exercise and the opportunity to make a good video for you guys. Now, another observation has to do with the age and wear of the old components. Now, I did say at the beginning that these components still had life in them. What I mean by that, if I take a screwdriver and try to move the inner sleeve of the bushing, I'm finding it very difficult to do so. And it's the same for the other 3 as well. The same for the ball joints, okay? I can move it with relative ease, but I have no play in the part, so this still had life in it, and the other one as well. However, if you take a look at the components in closer detail, you have signs of wear. For example, you can see here how the rubber is detaching from the bushing flange, okay? It's even worse here if you take a look. By contrast, on a new bushing, these are properly glued together. Thirdly, you see that the inner sleeve is actually starting to rip from the bushing's rubber. Okay, if you take a look here on the edges, you see there are lines of cracks, and the same here. Okay, the cracks are fairly obvious. So these components do show their age. They have 11 years. So it's not really a bad thing or a bad idea to replace them right now. And in the context of replacement, a key thing to keep in mind, which I have already emphasized in the Sportage suspension video, is that new components should always be installed in the same orientation the old ones were removed from. Now that's because bushings and other components as well may be designed such that they deflect differently or react differently depending on the direction the load is coming from. To give you a hypothetical example, this bushing or a similar bushing, for example, may have a certain deflection if you apply a certain amount of force vertically, but it may show a different deflection if you apply the force horizontally. So if you're not careful to install new components with the same orientation, the handling characteristics of your car are definitely going to change, and the results may range from premature wear of the components to non-compliant suspension, and in the worst case, heaven forbid, accidents. So before we remove anything, we want to make sure to mark or verify that we do have markings showing us how the initial components are installed and how we need to install the new components as well. And in that context, let's start with the ball joint. Now, normally you don't expect ball joints to have an orientation. But interestingly enough, in the case of these control arms, if you look closely, you see that the ball joint's body has two opposite notches and they align with this point here. The manual, as I'll show you later, actually calls these timing marks, oddly enough. It's important to know that when we press in the new ball joints, we need to align the notches with this dot here. It's the same on the other side as well. Here's the dot and the two notches and the three parts align. Also, the same manual tells us that the circlip here that secures the ball joint needs to be installed perpendicularly to the timing line. Okay, so this is our line. So that's another thing that we'll have to keep in mind. And let's now take a look at the left-hand side control arm. This is the front bushing. And what we notice is this dip on the side rubber aligns with this marking line right here. Here's the rear bushing. Again, this line is aligned with this dip in the rubber. On the same note, here's the right-hand side one. Again, the line aligns with the dip, whereas the one from the back, again, aligning with this line here. So these will be our markings when we press the new components in. With regards to the pressing depth of the bushing, the metal flanges are pressed thoroughly against the control arm's sheet metal. However, if you take notice, it looks like the flange here is pushed slightly less than the one here. And I'll actually show you later that the manual does say that there are some special tools and there are two different pressing heads for the front and rear bushings to make sure that they're pressed to the same depth. But in practice, it seems that the difference is very, very small. And it is hypothetically important to get the alignment just right, because if the bushings are pressed too much in or too little in, they're gonna pull the control arm towards the back or the front, and that's gonna slightly affect the caster angle. Now, obviously, I don't have the pressing tools from Land Rover, but we'll talk more about that when we get there. For now, we have our markings. We know how the components needs to be pressed in. So it's time for the removal or pressing out of the 4 bushings and 2 ball joints. And let's start with the ball joints. And to do that, the first thing we need to do is to remove this snap ring which sits underneath the control arm. Now, unsurprisingly, in my case, this and the one from the left hand side seem to have slightly rusted into place. So first of all, I have to break the rust seal. Here's the left control arm in a small vise. And first and foremost, with a screwdriver and a small hammer, the plan is to beat on the snap ring until I start to see it spinning in place. And about a minute later, you can see that I've got it to move, which means I can now try and extract it. And eventually, with the help of a flathead screwdriver, I managed to raise up this part over its channel here. Now, one thing that you should be careful of when trying to remove them, because these are effectively springs. Once they're no longer held in place, they can just jump all over the place, so do be careful. And now I'm just going to gently try and pull the entire circlip outside of its channel. Okay, it's almost out. And there it is. And sure enough, with the help of the pair of pliers, I was able to remove it with no damage. Hooray! And here's what the manual says for the ball joint removal. It says we should use some specialized Land Rover tools, which again I said I don't have, but that shouldn't be an issue. Remove the upper arm, already did that. Remove the dust seal, the seal retainer, and the circlip. Now we just struggled with the circlip and got it out. The seal retainer is what actually is holding the dust boot in place, and we need to remove the dust boot in order to have a place to put our cup that will press the ball joint out. And they are referring specifically to this strip of metal. You see that's holding the dust boot in place, and which looks like this, and it shouldn't be terribly difficult to remove. And indeed, with a flathead screwdriver, you can simply press on one of the heads to again pull it up, because it's not that rigid. And here it is out. And we should now actually be able to pull the dust boot out. And here it is removed. And now that we've cleaned up, here's a very interesting observation. So remember how I showed you at the start that there are these so-called timing marks and we need to align with them? Well, if you take a look, the timing marks are actually aligned with the front bushing. And if I now turn it, you see that the ball joint actually has more room to move towards and away from the front bushing than it has side to side. But this odd shape is actually what allows the front and the rear wheels as well to have that very, very large articulation in off-road environments. Next up, let's soak the edge of the ball joint in penetrating oil and let that work its way for a while. And while the penetrating oil is doing its thing, I did go and buy two different types of ball joint extractors. This is the classical one with the big C-shaped vise and various extensions. Though this was not my first preference because these do have a tendency to bend. And knowing that there's gonna be some amount of force needed, especially for the lower ball joint from the lower control arms, I didn't really trust this design very well to hold up. So most likely I'll be returning this, but I have it for now as a backup. And instead, let me show you the other extractor that I got. This is how it looks like. It's not C-shaped. You see the load is supported equally on both sides. And the idea is this is designed for vans and larger vehicles, so it should be more suitable for our Range Rover and smaller cars as well. Also, I can easily remove these rods and purchase some solid steel ones, longer ones, that can make this be bigger. In case, for example, I need it on the lower control arm ball joints. These are M16s, by the way. So this is the one I plan on working with and the one that I plan to keep. And here is our pressing setup. As I just said earlier, I actually needed to customize the tool because the two rods were actually too short for me to fit the cups I needed. So I ended up buying a 1 meter M16 10.9 grade steel bar, cut it in half, and now I have a lot of flexibility on how large or how small the press needs to be. And I set it up for 21 centimeters between the two blocks. And as you can see, I'm using a large 68 by 58 millimeters, that's 68 exterior, 58 interior millimeter diameter cup holding the control arm. And then there's a 46 by 36 millimeter small cup that actually will be pushing the ball joint from below as I'm tightening. And I'll be using a 24 millimeter hex bit with a breaker bar to apply force. And I also needed to secure the entire setup in a vise. And let's see how it goes. and now I'm feeling some resistance, and I needed to swap the previous cup with a 30mm long hex bit like you see here. And let's continue. And the ball joint is out. So here's the control arm with the removed ball joint. And now let's tackle the two bushings. And the instructions in the manual tells us to first raise the two bushing flanges, and then using a hacksaw we need to cut them from the bushing, obviously making sure not to affect the control arm in any way. And then we are able to press the bushing out using two cups of appropriate size. So I will be using a chisel, looks like this, and a pretty hefty hammer. And you see I've already had some success on this side, so I can continue. And here we have the flanges from both bushings on the left side rolled up. Now, slicing the heads of these bushings with a manual hacksaw is definitely going to be a very tedious job, and it's going to take quite a lot of time. If you happen to have something like a linear saber saw, an electrical one that cuts like this, for example, that's probably the best tool to use here. Unfortunately, I don't have one of those. What I do have, however, is an angle grinder. Now, you can work with an angle grinder. As you can see, I've already made a cut here using it. But if you do so, pay extra attention and take your time to not damage the control arm in any way. And here's how a angle grinded bushing looks like. Now that this is done, we can actually fit a cup from the bushing extractor on this side, supported by the control arm, and with a second cup, smaller one at the back, we can push or press the bushing out. And here is the pressing setup. So the large cup is 58mm outer diameter, 48mm inner diameter, and this sits on the surface of the control arm in the place that has been freed up by the removal of the bushing flanges. And the small cup, which actually will push the bushing out, is a 44 outer diameter by 34 inner diameter. I'm holding this nut of the press in place with a 24mm offset wrench held against the floor, so that I can turn this with a breaker bar. And it is out. So here is the removed bushing. But now I have a problem. Apparently the 44 by 34 cup is a very snug fit against the inside of the control arm, and now I have to press this one out as well. Similar to what happened with the Sportage a while back, so that's rather funny, I suppose. And here's where the bushing was sitting. Now I'm going to work on the second bushing. So here's the second bushing after I remove the flanges with the angle grinder, just as before. And here's exactly the setup from before: 58 by 48 the bigger one, 44 by 34 the smaller one. I don't have anything else smaller than this, so even though I know that I'll have to press this out because it's a snug fit, at least personally I don't have any other choice, but it's not too difficult. So let's see how it goes. And it's out. All right, so here's the second bushing removed, and next to the first for good measure. And finally, here is our left side control arm with both bushings and the ball joint removed. which means that I can start prepping this one for painting. And while the layers of paint are drying on the left-hand side control arm, I'm gonna start working on the right-hand side one. Now the removal of the components is effectively identical, so I won't film in too much detail, but I will give you the highlights. Just as before, I'm gonna start with the ball joint, starting with the removal of the circlip. Here's the circlip removed, and then the spring that's holding the dust boot in place, together with the dust boot. Here is the pressing setup for the ball joint, identical to the one from the left-hand side, so 68 by 58 receiving cup and a 30mm hex size to push on the ball joint. We broke the rust seal, which is perfect. And it is out. So here is the ball joint pressed out from the control arm. And next we will bend the flanges of the two bushings with the hammer and chisel. And here is the extraction of the first of the two bushings. And out it came. Here is the removed bushing and the control arm. And what you can notice here is that for this one I didn't actually need to cut anymore. What I did, I just spent more time with the hammer and chisel to the point where I raised or crushed the two flanges to a near vertical position, such that the large cup fitted directly on top without the need to saw them or cut them in any way. And lastly, here is the removal or the fourth and final bushing. Okay, this one popped a bit. And out it came as well. So here is the fourth and final bushing, again without me needing to cut the flanges because I pushed them all the way towards the inside so that the cup fit. And here is the control arm without bushings and ball joints, ready for painting. And now it's time for lunch. And with regards to painting, which I'm doing primarily for aesthetic reasons, I just want these control arms to look a bit better, but also to give them additional protection. I'm gonna go through a number of stages. Stage 1, applying a coat of rust converter, and you see it here applied on the left hand side control arm. In stage 2, I've applied 2 coats of primer on both sides of the control arm. And finally, here is stage 3, which represents 2 coatings of black paint on top of the primer. Here's the back of the left side control arm. And here is the front. I think it turned out pretty okay. Again, I wasn't aiming for perfection, but it definitely looks better than before. And now we are ready to begin installing the new bushings and ball joint to this control arm. And now that all the painting is finished, let's begin the installations. Starting with the bushing from the front of the left control arm. Here is the bushing, and remember the markings that we observed when we removed the old bushings, in the sense that the one at the front should align something like this, okay, with that line in the control arm aligning with the small dip in the rubber. And I've actually drawn this line here, so it's easier to do the alignment before I start the pressing in. And if you take a closer look at the bushings, the new ones, you'll see that all of them actually come with the flanges slightly pre-bent towards the interior, which is very good because this goes together well with the pressing depth that the manual asks us to be careful with. Namely, these instructions for installation, where it says installation caution, make sure the correct special tool is used to install the bushings to the correct depth. And you'll notice that while the receiver during the push is the same, 204532/1, the same as the one here, The actual cups that do the pushing are slightly different. So for the rear bushing, it's 204532/3, whereas for the top bushing is 204532/4. And if you look at the description of the tools, clearly the two heads are slightly different, as you can see. So 532-3 is gonna push the bushing slightly less than 532/4. And with all of this said, let's start pushing bushings in. And here is the pushing setup with a few mentions worth making. So the receiver cup 58x48, the big one, the pushing cup 54x44, and you see this one fits flushly against the surface of the rubber, and because the lips of these cups are quite wide, they're not gonna tear or cut the rubber in any ways. But if you have, for example, sharper cups, something, I don't know, like this or something, maybe consider using an intermediate washer to apply the pressure more uniformly. Otherwise, as I said, you risk cutting the rubber and you don't want that. Now, a small trick that I used is I kept the bushings in the freezer for a day or so to slightly shrink them and make them easier to fit. You can see the bushings marking here that we made earlier, aligning with the line in the control arm. And the setup is made stable by the wrench that's holding the presser nut in place. So let's see how it goes. And we're now at the point where the bushing has its flanges touching on the control arm. And now I'm just going to push a little bit further to slightly straighten up a bit the flanges, because remember, the bushing on the front is pushed inwards a bit more than the one at the back, according to the state of the old bushings before removal. And here it is. We have the dip aligned with the marking, and the flanges are slightly straightened, so just as the old one, which is absolutely perfect. And this is looking really good, which means we can proceed with the next one at the back. And here is our rear bushing, and here is the dip in the rubber and its corresponding line that has to align with this line in the control arm here. So same setup as before. And here is the bushing fully pressed. And obviously I did make sure not to press it as deep as the one in the front, as I explained before. But otherwise it's flush with the control arm and looking very good. So one more thing left to do here, and that is to install the ball joint. And here it is, our brand new ball joint that is delivered with a plastic cap for protection, which we've removed obviously. And here is our ball joint pressing setup with the pushing cup of size 48x38 and the receiving cup 54x44. And here we go. And that is it. So here is the installed ball joint, and I forgot to mention before the press, but I did pay attention. Remember, these markings should be aligned with this point here, which the manual calls timing, oddly enough. And together they form a straight line to the front bushing. So we did align them as expected. Just like it says here, make sure the timing marks are aligned, like so. And then one more thing we need to do is when we install the circlip, it tells us that the circlip holes need to be rotated by 90 degrees from the timing marks. So we'll have to pay attention to this particular detail as well. As for the circlip, the ball joint kit also gave us a new circlip and a new nut, which we will obviously be using. And here's what I'm doing to install it. I temporarily reinstalled the protective plastic cap came with the circlip from the top and glided it down using this small pair of pliers that fits into the circlip's teeth to be able to pull it apart. And then with the flathead screwdriver, as I'm pulling the front of the circlip apart, I'm pushing from the back. And after a bit of struggling, I managed to seat the circlip in place, as you can see, and with the correct orientation, so the two heads are pointing straight towards the back of the car, as I explained earlier. This left-hand side control arm is now ready for installation. But we won't do that just now. Instead, we will install the components on the right-hand side control arm as well. So here is our right-hand side control arm, and the first bushing will be the one from the front. And here's the now familiar bushing setup, and here's the bushings marker aligned as needed. Towards the end, I'm switching to a breaker bar. And here is the bushing pressed in. And here is our fourth and final bushing with the line here to align to this part of the control arm. Here's the fourth bushing setup with the correct alignment. And here is the fourth bushing pressed in as well. So now only the ball joint is left. Here is the ball joint pressing setup, identical to the one from the left. Again, pay attention to align the markings on the ball joint with this notch over here, so-called timing. And here is the pressing in. And that is it. And here is our pressed ball joint. And now the only thing left is to install the circlip. And here's the circlip installed as well. Remember, it should be 90 degrees perpendicular to the timing direction, which is the direction between the ball joint and the front bushing, so like so. And the circlip goes like this, with its two heads pointing towards the back of the car. And with that said, our right-hand side control arm is ready for installation as well, which means that after I apply some touch-up paint where I added these scratches and then go grab a spot of lunch, we can go to the car and install the parts. Hooray! And here we are at the car on the right side. And before installing anything, let's spend some time to clean the areas where the bushings are going to sit. And for that, use a metal brush, or in my case, a metal brush and a drill. Something like that. And then some brake cleaner to make sure that the areas are clean and rust free. And here's how it looks like after a bit of cleanup. We don't mind too much about that paint there. What we want to remove is any signs of rust that may have built over time and which may restrict us from pushing in the control arm and its bushings. And let's first check the steps for the installation as given in the workshop manual. So first and foremost, they do recommend, but it doesn't say it here, to put in new nuts and bolts, which I did get. So first of all, we're gonna put the nuts and bolts, but don't tighten them fully just yet. We will then connect the upper arm to the wheel knuckle and tighten our new nut to 70 Newton meters. We will then secure the stabilizer bar link. However, this torque is incorrect. It's not supposed to be 115, it's supposed to be 175. And then we proceed to connect the brackets for the various wires and hoses, taking note that the bracket for the brake hose takes 23 Newton meters, and the other two brackets, namely for the height sensor and the wheel speed sensor and so on, take 10 Newton meters. We are then supposed to put a jack underneath the lower control arm and then raise the entire suspension close to the wheel, so that the difference between the top of the arch and the center of the hub is 466 millimeters, and only then can we tighten the nuts and bolts that go through the inside of the bushings to 175 Newton meters. And then we're supposed to install the heat shields if we remove them, and then we can put the wheel directly, torquing the wheel nuts to 130, 140 Newton meters. Suspension ride height calibration hopefully will not be necessary. Back to the car. Here is our right hand side control arm, and here are two brand new genuine nuts and bolts from the Land Rover dealership. Regarding these, given that the components on our car were 11 years old, I didn't really want to take any chances and reuse the old bolts, because I didn't know in what state I'm gonna find them. As it turns out, they are fairly reusable, they just need a bit of cleanup. But in the event that I perhaps would have needed to cut them or something, I would have had to wait until I could source new bolts. So I tried to prevent that by simply buying new bolts from the head start. It's an expense well worth doing. I did this on the Sportage as well, and I recommend that you also consider doing it. Now, something that should hopefully help you or whoever else is gonna have to remove these bolts next time over how many years in the future would be to coat this part of the bolt in some anti-seize of your choice. In my case, I'm gonna use the old Techstar Ceratec, which I use as an anti-seize for brake discs, and it's doing a very good job. The rationale being that that should prevent humidity and dirt from getting in and from rust building up over time and so on and so forth. However, do remember that we did struggle, and we will be struggling again, to actually put the bolts back through the bushings, because we have to go behind the air springs and so on. And if, for example, you put grease on this part and you'd start fiddling with the insertion of the bolt, you're gonna smear grease all over various other components in the chassis and so on, and you don't really want to make a mess. So as an alternative, what I'm going to do actually with a screwdriver or some other tool of my choice, I'm going to put anti-seize inside the inner bushing sleeve, so through here. So here's the end result. Hopefully you can see the grease inside. Same in this bushing as well. Now, first things first, let's just put the control arm back. Okay, here it is. A small amount of struggle, but it got in. Now let's put this bolt first, because it should be a bit easier. Okay, there it is. I just need to push it a bit more. Like so. Now for the second bushing, I'm gonna have to again go with the bolt behind here, and that makes it rather impossible to film, so I'll just show you the results when I'm done. Okay, with a bit of struggle I managed to push the bolt in. However, do take note that with the solution I chose to grease the inside of the bushings, some grease came out with the threads, so it's absolutely mandatory to wipe that off before we put the new nut in. So here is the cleaned up bolt and the nut. So perfect. We have installed the two new bushing bolts. Next thing, we need to connect the ball joint to the knuckle. For that, first you may need to remove all these bindings that kept the knuckle in place. And here are the two parts aligned, first and foremost. And here is the new nut that was delivered with the ball joint. Apply some medium strength thread locker if you want, for good measure. And then tighten the nut. It's a size 18. Remember, if you want to hold it in place, use a Torx T30. Okay. And now we need to tighten the nut to 70 Newton meters or 52 pound-feet. Now I'm going to use a crowfoot extension, and as I explained in the past, to get the correct amount of torque, always put the extension perpendicular to the torque wrench. So here's 70 Newton meters. That's it. And now I'm gonna jump steps a bit because I want to first properly torque the two bushing bolts before installing the anti-roll bar link and so on, because this is when I have the most available space and the biggest chance to insert the torque wrench. Which means that I can now link to the first steps that we did at the very beginning, which was to deflate the air suspension and make those measurements from the top of the fender to the wheel. Because what we have to do now is to put a jack underneath the lower suspension arm and raise the entire front suspension on this side until we get to that distance from the manual between the center of the wheel to the fender of 466 millimeters. And we did those measurements at the beginning to confirm that we're in the ballpark, given the fact that, you know, the suspension on this car is a bit old. So now, why did we deflate the air springs? Well, if the springs have too much pressure in them, such as, for example, when the car is in off-road height, when there is a very high amount of pressure in the air springs, you do run the risk of raising the suspension and the air shock actually then raising the chassis of the car from the jack stands over there. Okay, and then there's a huge risk of it destabilizing and heaven forbid falling to the ground, and you can imagine the risks in that scenario. So that is why it was extremely important that I deflate the airbags, to get the smallest possible resistance when I need to raise the suspension in order to tighten the control arm bolts. And I'm actually using the car's own jack for this, placed underneath the lower control arm, as I said. And it doesn't take that much force. You can actually twist it by hand, though it gets a bit tiresome. So then you can just use, for example, a screwdriver or something to create a bit more leverage. And about 5 minutes later, here is the suspension raised to about 466, 67, give or take a few millimeters. So in the ballpark. And now, just as we did when we removed the control arm, we secure the bolt in place with a 9mm offset wrench, and then with another wrench of our choice we start tightening, 21mm in size. About 10 minutes later and a decent amount of elbow grease, I've tightened both nuts as much as I can by hand, which means now it's time for me to bring the torque wrench with a crowfoot extension. So here's my larger torque wrench with the 21mm crowfoot extension installed perpendicular to the torque wrench. And for the rear bolt, I'm holding the bolt in place with a 18mm offset wrench from the front. And then it may be a bit of a struggle. You may need to first fit the crowfoot extension and only then arrive with the torque wrench. And eventually you'll be rewarded with a lovely click. And here's a bit of comedy moment for you. I cannot fit the crowfoot extension and torque wrench on this nut because the head of the torque wrench keeps bumping into this heat shield. So I ended up removing the two front bolts of the heat shield, just as I did on the left side, so this one and that one as well, to be able to push the heat shield back and make room for the torque wrench. And then I spent a good amount of time trying to fit the torque wrench to that crowfoot extension, but the problem is, no matter how much I tried, the torque wrench ends up hitting the knuckle here and I can't move it at all. I tried turning the steering wheel left to right and all I got was a suspension fault in the dashboard, obviously because the height sensors at the front are disconnected. Now I'm sure there are some fancy torque wrenches out there with flexible heads, but I don't have one and I'm not going to give up on this. I want to torque it to spec, which means the only thing that I can do is to again disconnect the knuckle from the control arm. The rationale being that with this bolt properly tightened and this one tightened fairly good as well, the control arm is gonna stay in its correct position once I disconnect it from the knuckle. So here is the nut removed, and after using the separator again, I can now lower the jack a bit and you can see that the control arm is staying in place while the knuckle is going down. So we'll obviously have to secure the knuckle again. And here's probably one of the more awkward torquing setup that you're probably going to see. So we have the small ratchet with a 9mm hex head holding the bolt in place. The ratchet is held against the chassis. And then there's the torque wrench, and as you can see, the crowfoot extension is slightly diagonal. I couldn't place it at 90 degrees because of lack of space. But even so, the torque surplus caused by the extension in length of the torque wrench through the crowfoot extension isn't really significant. I should set it to about 170 to achieve 175 at the crowfoot extension right there. And with that said, here's the second very satisfying click. And we're done with the second nut as well, which means that now I can reconnect the knuckle to the upper ball joint permanently using exactly the same steps that I've already showed you, so I won't film that again. And after all that is done and the knuckles reconnected, don't forget to reinstall the two bolts for the heat shield, the one from here and the one from there. 10mm hex, both of them, tightened by hand. And now we can finally remove the jack. All right, next up, anti-roll bar link. And now if it happens after you remove the jack that the sway bar link's bolt is a little bit too high by a few millimeters and you can't easily fit it in, again, use the jack and raise the whole setup by a couple of millimeters until you are able to actually push the link with your finger like this. Also, very, very important, as the manual says as well, when you get to this point, do not forget to reinstall the steel washer that needs to go on the side of the link. And only then you can begin tightening. And the tightening setup is similar to the one from removal. So we need the Torx T50. And in my case, I'm using a bit with a small wrench that jams against the control arm to hold the ball joints thread in place. And then I'm twisting the nut. Again, I'm reusing the original nut because it's in good shape. It's not damaged or anything, and I don't have a new one. And then I'm going to tighten by hand using the offset wrench. And here's my torquing setup with the torque wrench, the 21mm crowfoot extension, the Torx T50, and a offset wrench that I can hold in place. And here is the third rewarding click. Again, 175 Newton meters, give or take. And now what remains are the brackets for the various sensors and hoses, starting with the bracket for the height sensor, which takes this bolt, Torx T30. Just make sure that the bracket's lip, this one here, sits between these two protrusions in the control arm. Because it's just 10 Newton meters, that's more or less hand tight, so I'm using this small extension and tightening it by hand. And that's it. Next up we have the brake line bracket, which uses this bolt with a 10mm hex head. And there's the bracket and bolt installed. Pay attention to this notch here where the bracket needs to fit. And I've tightened the bolt by hand and I need to torque it down to 23 Newton meters. But again, because of the tightness of the space and the awkwardness of the bolt's position, I can't really fit the torque wrench, so I'm using the offset wrench and just tighten it fairly snug by hand. And finally, we're up to our last bracket, which is this one here that goes into this notch here, and it has a similar Torx T30 bolt. This one holds the wheel speed sensor on the right side. And at least this one can be torqued down because of the easy access, so 10 Newton meters. And that is it. Which means that at this point, we're done with this side. We can install the wheel and install the lug nuts as well. And after a small break, we're back to install the left side control arm as well. And it's obviously going to be the same set of steps, so I will only show you the highlights. So we're gonna start with the cleanup of the locations where the bushings will be seating using a metal brush. And here are the areas all cleaned up with some brake cleaner as well. And here is our control arm with the inside of the bushing inner sleeves all greased up, in the hopes that this will prevent the bolts from seizing in the future. And let's put the control arm in. Okay, this wasn't too hard. Let's put one bolt in. Okay. We then need to clean up the bolt threads from any grease that came from the bushing. And once we visually check that the threads are not covered in grease, just put the nut in by hand to secure the bolt and prevent it from coming out. For the second bolt, we need to put it through the back here. And with a bit of struggle, here's the second bolt in, and here's the second bolt cleaned up and with the nut covering the first few threads. Next, use a 9mm hex to hold the tip of the bolt in place, and then with a 21mm hex wrench, tighten the nut by hand up until it's very close to the chassis bracket but not touching it. You still want the bolts to be able to spin freely at this point. And here we are after a bit of manual labor. So the nuts are tight. You can't really move the bolts back and forth anymore. However, the control arm still spins freely around the bolts. Now it's time to jack up the lower suspension, remove all of these ropes and everything, and do the initial connection between the knuckle and the control arm, making sure to reach the distance between the center of the wheel and the top of the fender of 466 millimeters. So here is the jack underneath the lower control arm, and I've connected the upper control arm to the knuckle with one of the old nuts, because we know we're gonna have to subsequently remove it in order to torque that bolt. And we raise the suspension, and here is the distance of 467 millimeters, so we are where we should be. And now we're gonna tighten this nut to 70 Newton meters to make sure that the ball joint is pressed all the way in. Okay, now let's torque the two bushing bolts. Now first we're gonna tighten both by hand as much as we can. And first we're gonna torque the rear bolt, because here we can put a spanner or wrench on its head, and we have fairly good access to put a crowfoot extension with a torque wrench at the back. And here is satisfying click number 1. Next up, we want to disconnect the ball joint nut. And at this point, it's safe to remove it all the way, because the suspension and the knuckle are still supported by the jack. Okay, let's bring the ball joint separator. Okay, now it's separated. That was easy, obviously. And now we're gonna lower the jack, secure the knuckle against with a rope or something temporarily to the strut. And using the same awkward combination of small ratchet and 9mm hex to hold the bolt in place and the crowfoot extension with the torque wrench, here is satisfying click number 2. And now that the control arm is properly torqued, let's reconnect it to the knuckle. So here is our brand new nut and some medium strength thread locker. And here are the required 70 Newton meters. Perfect. And now we need to lower the jack almost all the way to the end, effectively to the point where it's very easy to insert the threads of the sway bar link through the corresponding hole in the control arm. And once you're there, do not forget to put the steel washer on the front of the sway bar end link, and then connect the two. And then with a Torx T50 to hold the ball joint in place, use a 21mm spanner or ratchet or wrench, whatever you have and whatever fits, to tighten the nut. Again, if you can, source new nuts. If not, and the old ones are in good condition, just reuse them. Again, here's the awkward setup for the torquing: torque wrench, crowfoot extension, and Torx T50 bit to hold the ball joint in place, and a small ratchet jammed against the ball joint. And satisfying click number 3. And we're done with the sway bar link as well. And yeah, nearly forgot. Normally you should do this after you torque the control arm bolts because you have more room, but you can do it after you tighten the sway bar link as well. Remember to put back the 2 screws that hold the heat shield in place, just like we did on the right hand side. 10mm hex and about 10 Newton meters if you need the torque, but I just tightened them by hand. And after the sway bar link is tightened, we need to reconnect the 3 brackets, again beginning with the one from the height sensor. And remember, this uses this small Torx T30 bolt, 10 Newton meters if you want to torque it. I'll tighten it by hand as well. And yeah, also pay extra attention, just like on the right side, that the bracket's notch goes between those 2 protrusions in the control arm. Otherwise, if you tighten it and the bracket sits a bit lower, you'll get incorrect height readings, and that might show you some errors on the dashboard. Next up, brake hose bracket. The bracket's notch goes here, and this is the 10mm bolt. Again, I'm gonna tighten by hand, but otherwise the torque is 23 Newton meters. And the last bracket is this one, connecting to this point here, and the notch going into this entry right here. And this holds the wheel speed sensor and the brake pad wear sensor. Now, to get access to the bolt hole, simply remove the brake pad wear sensor temporarily from the bracket. And just like on the right side, this one can be torqued easily, so let's end with a satisfying click, 10 Newton meters. And we're done. And obviously don't forget to reconnect the brake pad wear sensor. Perfect. Now we can put the left hand wheel on as well. And with the car on the ground, let's not forget to torque the wheel nuts. I'm using 130 Newton meters and, as always, torque in a star pattern. Alright, I'm done on this side. I'll do the same on the other one, and the car is ready to go out. And here we are during our test drive, and it's an interesting set of results. So first and foremost, the car does feel slightly more composed. Wasn't really expecting it because, you know, as I explained at the beginning, I think the upper control arm is not really load carrying. The entire weight of the car sits mostly on the lower control arms. However, still, for the part of load that it does carry, the fact that we changed the components does make the suspension a bit more settled and compliant, which is very, very good. On the other hand, if I quickly brake, okay, the knocking is still there, and we're still suspecting the lower control arm bushings to be the culprit. But what's interesting is the knocking is now more pronounced, and if you think about it, it sort of makes sense, because previously when the car ran over a bump, a certain amount of the energy was absorbed by the old ball joint and bushings from the top, which no longer offered as much resistance as when they were new. However, now, since they are new, they offer more resistance, so the lower control arm takes a bit more of the effort. So all in all, we're happy with the results, but in a few days' time we need to tackle the lower control arms as well. And one more thing to mention, normally because we've touched suspension components, we right now should go and do an alignment as soon as possible. However, given that in a few days I'll do the lower control arms as well, it doesn't really make sense to do so. I'll do the alignment after I tackle the lower control arms, and then I'll get back to you with the results. And now it's time to move on to the conclusions, but before that, fast forward a couple of weeks after I finished doing the bushings and ball joints on the lower control arms as well, as I said. And here are the results from the alignment. This was performed towards the end of September. The first two lines deal with the toe-in angle, and this, even after adjustment, is a bit off because we discovered some play in the steering rack, and we're gonna fix that, but that's a topic for a different video, and we're not gonna discuss this now. The important values for us are the camber angle, in Romanian unghiul de cădere, and the caster angle, in Romanian unghiul de fugă. Now these are the nominal values, the intervals given by the manufacturer, and these are the values we had before alignment. And for the camber angle, you'll notice that the values were within the allotted interval, so the adjustments were fairly small. And for the caster angle, you'll note that the original values were outside of the allowed intervals, but they have been successfully adjusted as well. And this obviously means, when focusing on the upper control arms, that the procedure we chose to insert the new bushings was sufficiently good so as not to cause a bad caster angle. So in all, we're very happy with these results. Now to the conclusions proper. Here are the parts that we have removed: the old 4 bolts, the abused 4 bushings, and the 2 ball joints. And first I want to just quickly talk about some procedural observations. First of all, concerning the reconnecting of the sway bar end links, you'll notice that it's fairly awkward to torque the nuts on these end links when connecting them back to the upper control arms. And after doing the procedure, I realized that it's probably a lot easier to disconnect the sway bars from the lower control arms first while on the car, and then disconnect the upper control arms from the car together with the end links still connected, and maybe don't touch the upper part of the end links at all. And obviously upon installation you'll have to tighten the lower end link nuts, which is going to be significantly easier because you have more room. And concerning the torquing using the torque wrench for all those, again, very awkward angles, I used crowfoot extensions, and they did a fairly good job, though I know that there exist some straight extensions for torque wrenches, and if you have them or if you can source them, it may be a bit easier to do the torquing with those. Lastly, you'll probably agree that this procedure is not among the easiest ones to do, but at the very least, this video shows you how to remove old upper control arms and connect new ones if you just want to source new control arms complete with bushings and ball joints, and you don't want to go through the hassle of actually removing these components as well. Now moving on to the costs, you'll probably be a bit surprised to hear that for the parts that I bought, so ball joints and bushings from Lemforder and the bolts I got from Britpart, I spent a grand total of about 120 euros. So each of the bushings was about 6 to 7 euros, and each of the ball joints was about 30 euros, give or take. On top of that, it's only natural that I also account a bit for the amortization costs of the tools, the crowfoot extensions, the ball joint separator and the bushing removal kit and so on. So I would round up the total financial cost of this operation to about 200 euros, give or take. And as always, I got competing offers. One of them was from a specialized Land Rover garage here in Bucharest, and they wanted about 600 euros for the entire operation, excluding alignment. And the dealership wanted way more than that. They wanted almost 1200 euros for the entire operation. So all in all, in terms of financial cost, this has been a job well worth doing. Not to mention the fact, obviously, that I've already driven the car for a good few hundred kilometers, and with all the upper and lower bushings and ball joints changed, and it feels almost brand new. And the feeling is absolutely amazing. It's like a totally different car. So with that said, as always, thank you very much for watching the video if you made it this far. If you enjoyed it or you found it useful, I would be very grateful if you considered subscribing to help the little YouTube channel grow and maybe reach other people that can benefit from these videos. And I wish you all a lovely day, and I'll see you next time. Thank you and goodbye.